Yes, this was. Yes, ट्रांस पे चल रहे थे ये तो बेसिक ही ट्रांस पे
Yes, sir.
Yes, what the difference between cis plating and transplating? What the uses?
Yes, sir. So, sir, cisplatin, the main difference is between the cisplatin and transplatin is of structure, sir. Cisplatin is platinum, uh, N Cl Cl. If the ligands which are attached are at cis position, then it is cisplatin, and in transplatin the same ligands are trans to each other. It is transplatin, sir, and cisplatin is mainly used in cancer treatment. And if we form cisplatin, we have PTCl4 2 negative, PTCl4 2 negative, then ammonia ligand Cl PT ammonia Cl Cl negative, and another ammonia ligand PT ammonia. So this is how the formation of cisplatin takes place from PTCl4 2 negative.
Yes. Any limitation of trans effect in coordination? Drawback and limitation?
Yes, sir. Some limitation. One limitation is that, sir, it is not always necessary that the complex follows trans effect. Sometimes the ability of the ligand also determines which particular ligand will be removed from the complex. So instead of following the trans effect series, the living ability of the ligand may also affect the reaction of that particular metal ion complex. So this is one limitation, sir.
Yes. How theories of trans effect? How many theories?
Theories of trans effect.
Yes.
Sorry, sir. At this moment, I'm not able to recall the theories, sir. Which are the theories?
Yes, pi bonding theory. Yes, no. Polarization theory.
Okay.
Yes. Two
Okay.
theories. Next, move on. Redox reactions. What is redox reactions? What the difference between outer sphere, inner sphere mechanism? What the uses example?
Mm, What was the other theory, sir? One is pi bonding theory.
Polarizing theory.
Okay, polarizing theory.
Two theories in transpect.
Okay. So redox reaction are those reaction in which the transfer of electron takes place. If we have transfer of electrons, then those reactions are known as redox reaction, and there will be a reducing agent or an oxidizing agent. Mainly it is of two types, or the two, it will follow two mechanisms: inner sphere mechanism and outer sphere mechanism. Outer sphere mechanism is followed in those in outer sphere mechanism. The transition of the electron takes place through tunneling. So with the help of the phenomena of tunneling, the transfer of the electron takes place. But in inner sphere mechanism, we have two complexes, A and B, and in one of the complexes there is an bridging ligand. For example, let us say A has an bridging ligand. So the transfer of electron is through the bridge, is through that particular bridging ligand. So we can say that, sir, if the transfer of electron is through tunneling, it will be an example of outer sphere mechanism, or it will follow outer sphere mechanism. And if the transfer of electron is through bridging or is through a bridge, then it will be an inner sphere mechanism.
Yes. Which factor affecting the redox reactions?
Factors affecting. So, for example, if we consider the case of outer sphere mechanism, then one of the factor is delta G value, or the change in the bond length. Change in bond length. For tunneling to take place, the bond length for tunneling to takes place, the bond length of the metal ion should be equal, so that tunneling may takes place very easily. So one factor is the bond length, sir, in case of outer sphere mechanism. And sir, in case of inner sphere mechanism, the main factor which affect the reactivity is the bridging ability of of that uh, that ligand, which act as an bridging ligand, which acts as the bridging ligand. So, sir, we can say that for bridging ligand, it should have at least two lone pair along with it. For example, if we have ammonia as a ligand with any metal ion complex, then it will ammonia will not act as an bridging ligand, or the or if it will it may have to act as an bridging ligand, then its reactivity would be very low. So main factors are, sir, for outer sphere mechanism type of redox reaction, it is change in the bond length, and for inner sphere mechanism, it is the bridging ability of the bridging group, of that group which acts as an bridging ligand.
Yeah, next move on two electrons transfer. What is the difference between one electron transfer and two electron transfer?
Sir, if the transfer of electron is of one electron, then it will be a single electron transfer of, or one electron transfer. And if the transfer of electron is of more than one electron, it will be known as two electron transfer. So if the number of electron transferred are two, it is two electron transfer. And if the number of electrons which are transferred is one, then it will be a single electron transfer. And sir, if more than one electron transfer takes place, then those kinds of transfer generally follows the outer sphere mechanism. And if a single electron transfer takes place, the mechanism can follow inner sphere mechanism or outer sphere mechanism.
Yes. Yes, good. Complete in coordination. Next, what the uses
Yes, sir.
useful of coordination chemistry in our real life, our society? Any point? 5, 10.
Yes, sir. So coordination complexes are used in many areas of our life. For example, in medicines, uh, a coordination complex cisplatin is used in the treatment of the cancer. Coordination compounds are also used in various types of enzymes or to perform the enzymic activity of any particular enzyme. Coordination complex are very useful. Coordination complexes are also useful in various kinds of biological processes. For example, the carbonic anhydrase, which is present in our body, which is used to disintegrate the H2CO3, or which is used to expel out the carbon dioxide from our body, uses an coordination complex of zinc 2 positive ion. So these are the major applications, sir, of coordination complexes.
Is there any drawback and limitation of coordination chemistry?
Any drawback and limitations of coordination? One drawback can be their variable oxidation states. So due to variable oxidation states, the study of the coordination complex become somewhat uh, difficult or somewhat complex to understand. This can be one drawback, sir.
Yes, good. Yeah, next move on spectroscopy. Your topic is your organic spectrum. Yes, no?
Yes, sir.
Other 5 number part.
Yes, sir.
Yes, what is spectroscopy? What the main application of spectroscopy?
Mm. Yes, sir. Spectroscopy composed of two terms, spectro and scopy. So spectro means light and scope is the study. So in lame terms, we can say that the spectroscopy is the study of the light. The main use of the spectroscopy is to determine the structure of the compound. So depending of depending upon our requirement, or depending upon the information that we need to get about that particular molecule, we perform different kind of spectroscopies. For example, sir, if we need to calculate the value of the excitation of the electron, then we use UV visible spectroscopy. If we need to find out the bond length, then we may use microwave spectroscopy. If we need to determine how many types of hydrogen atoms are present in the particular molecule, then we may use NMR spectroscopy. So depending upon our requirement, different kinds of spectroscopies are present, which helps us in study of the which helps us in determining the properties or the molecular structure of the molecule.
Yes, good. What the difference between wavelength, frequency, wave number?
Yes, sir. So, the distance between the two consecutive crest or trough, the wave is looks like this. Like this, sir. So the upper part is crust and the lower part is trough. So the distance between the two consecutive crusts or the distance between the two consecutive troughs in a wave is its wavelength. Is its wavelength. Wavelength is denoted generally by the symbol lambda. Another one is sir frequency. Frequency is generally used to express the energy of the molecule. The energy of the molecule is given by the formula E is equal to h mu, and the third is the wave number determined represented by mu bar. So the number of oscillations that a particular wave makes in 1 second are its wave number.
Yes, good. What is electromagnetic radiations?
Yes, sir. So electromagnetic radiations are the radiations of different wavelengths which propagate uh, which can propagate without any medium or can also propagate in any particular kind of medium. So the we can say that, sir, so to explain the wave nature of any particular wave nature of the photons or wave nature of any particular thing, we need radiations. And sir, radiations are generally studied with the help of electrochemical series, uh, which uh, which is arranged according to the energy of the uh, different kinds of radiations which are present. The electrochemical series is, sir, radio, micro, IR, visible, UV, X-ray, and gamma ray. So if we move from left to right, the energy of the radiation goes on increasing, and if we move from right to left, this is the increasing order of the wavelength. So these are the different kinds of wavelength, the different kinds of radiations that we study or which are more helpful to us. And so from this we may determine that the gamma radiations have highest energy and uh, lowest wavelength, and radio waves have least energy and highest wavelength.
Yes, what the energy order of cosmic ray, radio wave, gamma ray, UV, visible, IR?
Yes, sir. This is the energy
Decreasing
order,
order,
sir.
yes. Energy order.
Radio waves are
Yes, decreasing order.
decreasing order.
Yes.
Yes, sir. So gamma rays have highest energy. Then we have X-rays. Then UV, visible, IR, Micro, radio. Radio waves are radio waves have least energy, and gamma radiations have highest energy.
The maximum is cosmic rays.
Yes.
Cosmic rays is highest, then gamma.
Yes, sir. Cosmic, gamma, X-ray, UV visible, IR, micro, and at last radio.
That's good. Next, move on UV visible spectroscopy. Yes, what the main application of UV visible?
Yes, sir. So, main application of UV visible spectroscopy is to first is to study the concentration of the various types of ligand. The another application can be, sir, is to study the adsorptions adsorptions of the various kinds of complexes, and sir, third is to study the difference between the homo-LUMO transitions of the electrons. These are the main applications of UV spectroscopy.
Yes. Range of UV visible. Determination of conjugation. Yes. Application of UV visible.
Yes,
What's
sir.
the range?
So the yes, sir. So the range of UV visible spectroscopy is generally from 190 nanometer to 800 nanometers, sir. From which from approximately 190 to 400 is ultraviolet range, and from 400 to 750 or up to 800 it is visible region.
Yes, good. What's the source of UV visible? Source.
Yes, sir. Sir, one source can be tungsten lamp. Another source can be hydrogen lamp in hydrogen lamp of Lyman series. Mercury lamp can also be used as a source for UV spectroscopy, sir.
Yes. What is Beer-Lambert law? What the main application of Beer-Lambert law in UV? Explain.
So, yes, sir. Beer-Lambert law states that the absorbance by any particular solution is directly proportional to its concentration and also to its path length. The molar absorption is molar absorption of any particular solution is directly proportional to its concentration and path length, sir. This is the Beer-Lambert's law, and the this is lone I. And if we derive it further, it will be reduced to absorbance is equal to log I naught by I is equal to epsilon Cl, where C is the concentration, L is the path length, epsilon is the molar absorptivity constant, A is the absorbance. And sir, this Beer-Lambert law is the principle of the UV visible spectroscopy. The principle of UV visible spectroscopy is Beer-Lambert's law.
Yes. Any limitation of Beer-Lambert law?
Yes, sir. So, few limitations are that, sir, Beer-Lambert law is applicable only if the solution under solution under consideration is not much concentrated. If the solution is dilute, then only the Beer-Lambert's law gives us the uh, true values. Another application is, sir, if the solution undergoes any kind of reactions such as association, dissociation, or precipitations, then the theoretical results obtained from Beer-Lambert's law and the experimental results would be different. Another limitation is that, sir, the refractive index of the solution should not change with time. So these are the few of the limitations of Beer-Lambert's law, sir.
Yes, good. Yes, what the difference between UV visible IR and NMR in organic?
Yes, sir.
Well,
Yes, sir. So the difference between NMR, IR, and UV is, sir, it is our requirement. Main difference is our requirement. If the radiation source is radio waves, then only the splitting, then only the spin of proton changes, because, sir, the energy of the radio waves are very less, so only spin of the proton changes. And this particular spectroscopy is NMR spectroscopy, which gives us information about the various kinds of hydrogen atoms or protons present. Then is the IR spectroscopy. For the IR spectroscopy, the source is IR radiations. It is also known as vibrational spectroscopy, and it is also known as vibrational spectroscopy. So to understand the different kinds of vibrations in the molecule, whether they are stretching or bending, or to determine the various kinds of functional group which are present in the molecule, which use IR spectroscopy. And last is, sir, UV spectroscopy, to determine the value of the homolumo energy transition, or to determine the homolumo energy transition, or to determine the concentration of any particular solution. We study UV spectroscopy, and the radiations which are used in UV spectroscopy are of ultraviolet and visible range. So, sir, these are the major differences among these three spectroscopies.
yes, good. Any similarities of these one?
Any similarities? One similarity is that, sir, all of these three spectroscopies uses their source as from the electromagnetic radiations. So whether we have radio waves or IR waves or ultraviolet rays, all of these are part of electromagnetic radiations. And in all of these, the electric field and magnetic field are perpendicular to each other, and also that is perpendicular to the direction of propagation. And the answer these radiations do not require any medium to propagate. So these are the main similarities, sir.
Yes. What is electronic transition? How many types of electronic transitions? In UV.
Which transition, sir?
Electronic transitions in UV.
Okay, types of yes, electronic transition. So we have mainly sigma orbital, then pi, non-bonding, pi star, and sigma star. So the selection rule for UV spectroscopy is delta S should be 0, and the transition will be from G-rayed to un-G-rayed or un-G-rayed to G-rayed. From this, sir, we can conclude that the transition are of the main transition are sigma to sigma star, pi to pi star, non-bonding to sigma star, and non-bonding to pi star. These are the major transitions in UV spectroscopy, sir. The transition from sigma to pi or from sigma star to pi star are not possible as they do not follow the selection rules of UV spectroscopy. These are the major transitions which are possible.
Yes. Which transition is allowed and forbidden and why?
Yes, sir. So that transition is allowed which takes place either from un-G-rayed to G-rayed orbital or from G-rayed to un-G-rayed orbital. If such kind of transition is there, then that will be allowed, and if the transition is from G-rayed to G-rayed or un-G-rayed to un-G-rayed, then that will be a forbidden transition. For example, sir, if we take sigma orbital which is G-rayed, and from sigma to sigma star which is un-G-rayed, so this transition is possible. But if we take sigma star and pi, sigma star is un-G-rayed and pi is also un-G-rayed, so this transition is not possible. And sir, if we take non-bonding orbitals, the symmetry of non-bonding orbitals are not defined, so the transition from non-bonding to sigma star or non-bonding to pi star takes place because the symmetry of non-bonding orbitals are not defined.
Yes. What is the difference between chromophore or optochrome?
Yes, sir. So whenever there is absorption of the UV radiation, then or whenever there is absorption of UV radiation or transfer of electron from lower orbital to higher orbital, then that particular absorption of the radiation will depend on the particular group, not on the particular element. So, sir, that particular group will affects the transition is chromophore. For example, let us say, sir, benzene. Benzene acts as an chromophore. We have phenol. It is an chromophore. Which group? The group due to which the UV visible absorption takes place. And sir, another is oxochrome. Oxochrome. Oxochrome is that group which itself is not involved in the absorption of the UV radiation, but affects the wavelength and the intensity of the chromophore. For example, sir, halides or any functional group like OH group, NH3 group, NH2 group. So those groups which themselves do not take part in the absorption of the UV radiation, but affects the chromophores by changing their wavelength and intensity. Those groups are oxochromes.
Yes, good. What the difference between red shift, blue shift, hyper shift, hypochromic shift?
Yes, sir. If the wavelength changes from lower value to higher value, or if we can say that if the wavelength increases, then it will be bathochromic shift. If there is decrease in wavelength, then hypsochromic shift. If the intensity increases, then it is hypochromic shift. Hypochromic shift. And if there is an decrease in the intensity decreases, this is sorry. If increase in intensity, hyperchromic shift, and decrease in intensity, hypochromic shift. And sir, if the wavelength increases, it is bathochromic shift or red shift, and if wavelength decreases, hypsochromic shift or blue shift. So depending upon the whether the increase or decrease is in wavelength or it is in intensity, we can define different kinds of shifts.
Yes, good. What is Woodward-Fisher rule? What is the main application of Woodward-Fisher rule?
Yes, sir. So Woodward-Fisher rules were used to determine the theoretical value of the wavelength, or we can say that to determine the theoretical value of the lambda max for which the transition takes place. So if we apply Woodward-Fisher rule on any particular molecule, then we can calculate the value of lambda max for that particular molecule theoretically, and that calculated value or that theoretical value is very close to the experimental value.
Yes, good. यस, आपका इतना पार्ट हो गया है, आईआर और एनएमआर है, तो थोड़ा आप रीजॉइन वंस अगेन कर लेना, तो थोड़ा वो भी करा दूंगा।
Yes, sir.
ठीक है, ओके, बाकी ठीक है। एप्लीकेशन इसके ड्रॉबैक और लिमिटेशन
Okay,
और है यूबी की।
ठीक है सर।